is to look at applications in 3 dimensions. So we're going to look at a 3D diagram and then calculate angles and height. That's what we're going to do today. So, okay, let's look at the first bit. A vertical mast is supported at the top by 2 cables reaching from 2 points, A and B. So if you look at the diagram below, there's the cable joining from A to T, and another cable from B to T. Okay. So the OT is a vertical mast. That's the vertical mast. The cable reaching from A is 36 meters long. That's the cable, which is already labeled for you. And the angle of elevation at an angle of 48 degrees to the horizontal. Point B is 24 meters from the base of the mast. So everything is labeled on the diagram. You don't have to draw it. So now from the diagram, we're going to work out the height of the mast correct to 3 decimal places. So obviously, if you use triangle OAT, you can work out the height of the mast. Okay? So you might like to draw this again over here. So by using this triangle, OTA, you can work out the height. Let's call the height H. And the angle is 48. So now you're going to use trigonometry to work out. So in this case, the appropriate trigonometric ratio will be sine. So write sine 48 equals to H over 36. And to find H, you just multiply 36 by sine 48 on your calculator, correct to 3 decimal places. So we'll do 36 sine 48 equal 26.753. 26.753. Double check is correct to the that will be meters. That's the height of the mast. So it's pretty easy, isn't it? Once the diagram's drawn, I think most of the time they're all given in the textbook. You just have to look at the diagram. Okay, we've got one more question to go through for this exercise. Part B, the angle to the horizontal of the cable reaching from point B to 2 decimal places. So you have to figure out this angle here. What angle does it make with the horizontal? Okay. But we already know the height, isn't it? So we'll draw this picture again. We've got the theta we have to work out. That's B, that's O, that's T. And then we have this length, 24. But we have the height now, which is 26.753. So we can use trigonometry to figure out the height, which is tan theta equals to opposite over adjacent. Then you can figure out theta. Yes? Well, you can't because that's 36 is in that triangle. This triangle doesn't have the length of the cable. Yeah. So it's actually, we're now using a different triangle. So let me use a highlighter to highlight this. So basically, we're now using this one, which is this one here. The one before is blue, which is this one. Which is this one. Oh, blue may not be good. But anyway. All right, good. So this is that one. This is this one. Okay, so not to get confused. All right, let's continue. We're going to look at this. So do shift hand to get the angle. Okay, let me see. Continue. All right, so what do we have? We have a calculator which you could use. So we do shift hand 26.753. Oh, that's pretty cool. 753. It's our diagonal. Divide by 24 equal to 48.10. Correct to 2 decimal place. 48.10 degrees. Okay, all done. Any question? We've still got one exercise to go through. Okay. Continue. We've got one more section to go through, which is exact values. This is new, and that's very, very important. You will use that again next year in 11 into the trigonometry topic. Make sure you learn this well. If you can master this, it will help you to learn year 11 mathematics, regardless whether you do advanced or extension 1. Okay, this is important. So pay attention. All right, let's continue. So we're going to look at exact values. So what we do is we're going to consider this triangle drawn in front of you. And on this triangle is an isosceles right angle triangle, both with side length 1. We're going to find the exact length of AB using Pythagoras. So you write AB square equals to 1 square plus 1 square. Okay? Which is just 2. So to work out the hypotenuse, we'll just write root 2. Root 2 over here. Okay? That's the length of the hypotenuse. Once we do that, we need to find the angles BAC and ABC. BAC and ABC. So you have to find these two angles. Now, how do I find this angle? Of course, you're not using trigonometry. We're going to find out from geometry. Now, because it's isosceles, these two must be the same, isn't it? So to work out this angle, you do 180 minus 90 divided by 2. That will be 90 over 2, which is 45. They are both 45 degrees. 45, 45. All right, label this on your diagram, 45. Okay, good. All right, now so in this right angle triangle, we got all the side length and angles given. So therefore, I could work out the exact value of sine 45, cos 45, and tan 45. Let's do that. So we're going to use this angle here. Okay, so that will be your adjacent, that will be your opposite, that will be your hypotenuse. Okay, so therefore, to find out sine 45 is opposite over hypotenuse, which is 1 over root 2. Okay. Cos 45 is adjacent over hypotenuse, is also 1 over root 2. And finally, tan 45 is opposite over adjacent, which is 1 over 1, which is equal to 1. We call this the exact value because it's exactly equal to 1 on root 2. Now, what if you want to check on a calculator? So if you do sine 45, it does not give you 1 on root 2. Right? It doesn't give you, it gives you 0.707. But is that 1 on root 2? We could try that, 1 over root 2 equal. See, it's exactly the same. But your calculator doesn't give you that. That's what we have to learn this. Okay? And if you do tan 45, you also get 1. That gives you 1, as we expect. Okay? So, we've got these 3 values so far. There's another 6 values we're going to find. And to do that, we have to consider a equilateral triangle. Equilateral. Let's look at the equilateral triangle. So the equilateral triangle has side lengths 2. All angles in an equilateral triangle must equal to 60 degrees. So they're all 60. Okay. Label all the angles on the triangle above. So you got 60 there, 60 in all 3 places. Okay. Once you do that, they want to draw a perpendicular line from the apex A to BC. So draw a perpendicular line. And the foot of the perpendicular, we're going to call that D. Okay? So draw a perpendicular line from the apex to the base of the equilateral triangle. And the point where you touch the base is the point D. And then we have to find the length of BD. Now, what would the length of BD be? It's going to be 1 because it's like an axis of symmetry. It's going to be 1. So the length is 1. Okay, 1. And once you do that, we can find the length of AD. Okay? Now, AD, you can use Pythagoras, isn't it? Because we've got 2 there, 1 here. We can use Pythagoras to work out AD. So write AD square equal to 2 square minus 1 square. 2 square is 4, 4 minus 1 is 3, so you get 3. So the length of AD is exactly equal to root 3. Okay, root 3. Okay, so now we have this triangle, root 3. Actually, I'll draw it over here again, so it's bigger. So we got 2, root 3, 1, and then you got the 60, you got the 30. Like that. So we're going to use this triangle to help us to work out the exact value. Okay, so let's look at this triangle. Work out BAD. Now, BAD is this angle. We know it's cut in half. The 60 must be divided by 2. You get 30, which is this 30 there. We just wrote down. That I've just written down. And label the size of BAD on the triangle. So that's this angle. So we've got the triangle B, and then A. Okay, this is a triangle. So I drew this again over here. So let me use a highlighter to show you. So what I just did is to took this triangle and put it over here. Okay, that's this triangle. Okay, now from this triangle, I could work out cos 30, sin 30, tan 30 because I've got the 30-degree angle, all sides given, as well as the 60-degree angle. So I could work out the exact value of these. Okay, let's work out the exact value from the triangle. So first we have to use, now if we start with 30, that means that this is the opposite, that's the adjacent, that's the hypotenuse. So now we have to use this triangle to work out cos 30. Adjacent of the hypotenuse is √3/2. Okay. Sin 30 will be opposite of a hypotenuse, which is 1/√2, like that. And tan 30 is adjacent, opposite of adjacent, 1/√3. Okay. So these are the 3 exact values you can get from the triangle. In addition to that, we can also get the exact value for the 60-degree angle. So in that case, you have to change. So I use a different color, the purple one. So now this will be the adjacent, this will be the opposite, but that stays as hypotenuse. Okay, so you got cos 60, which is adjacent of a hypotenuse. Adjacent of a hypotenuse is okay. Adjacent of a hypotenuse will be yeah, so it will be 1/2. So right, 1/2. Okay. Next one will be sin 60 will be √3/2. Like that. So you see there's some connection between these ones, and tan 60 is opposite of adjacent, which is just √3. Okay. So we've got all 6 values. Now these values are absolutely very important. People in year 11 find trigonometry difficult because they haven't learned this very well. So you now have this half year to learn this. I think after a few weeks you should know them very well if you actually practice them. So let's summarize all this on the table below. And if you can memorize this table, you know a lot about maths. Okay, so sin 30 is half, cos 60 is half. See how I do it? I know both of these are half. They both have the same values. Sin 60 is √3/2. Cos 60 is also, cos 30 is √3/2. Okay? And both sin 45 and cos 45 is exactly the same. Both are 1/√2. And then tan 30 is 1/√3. Tan 60 is √3. And tan 45 is 1. So we got all 9 values. If you can memorize it, you will do very well in tests. Memorize. Okay? So you either memorize the table or memorize the triangle. Okay? But if you memorize the table, it's much quicker. You should be able to do this under 10 seconds. Okay? Alright, so let's do the next problem. How does it help us to solve this? Okay, so let's look at this problem. Find the value of y in surf form. So this is adjacent and hypotenuse. Okay, so the adjacent will be y/8 equal to cos 30. Okay, that's your working out. But when they say exact value, you're not expected to use your calculator to do 8 times cos 30 because it gives you a decimal place. It doesn't give you a surd on calculator. Therefore, we have to know what cos 30 is. Now, if you memorize the table, you will know cos 30 is √3/2, which you just substitute in there, √3/2, multiply that by 8, and that will be 4√3. Now check, is that actually same as what we have? 4√3? Yes, it is. Same thing. But they want to be exact form. So you need to do it like that, exact. All right, now when we try to memorize things in maths, what do? We do that a lot of times repeatedly. So I have prepared for you 6 of these. You can do more in your book. So to write it down 6 times, so if you do it 10 times, it's hard to forget, isn't it? So if you just start with half, half, look at how fast I do it, just less than 10 seconds. 1 on root 2, 1 on root 2, 1 on root 3, root 3, done. Do that 6 times and do another 4 times in your book, another 4 times in your book. You will know them very well, and we may have a competition next week to see who can do them the fastest. Okay, all right, let's finish this. Okay.